So, what's up, guys, and welcome to this video where we'll be going over June 2023 paper 1. Let's go. So, for the first question, we just need to integrate this expression here. So, what I'm going to do is I'm going to take out the factor of 1 over 3 first. So, we have 1 over 3, and then we have the integral of x to the half of 2x minus 5. And I'm going to expand the brackets out. So, we have a third. And then the interval of this will be a 2x, and then it's a half plus a 1. So that's going to be a 3 over 2 here. And then we'll just have a 5x to the half here. And now we need to integrate this. So integrate this, we'll start the third out here. We'll integrate this, we'll get a 2x plus 1 to the power, so 5 over 2, divide by 5 over 2. And then we would get a 5x. And that's a 3 over 2, and then we are just going to divide by that. So we'll divide by a 3 over 2, and then if we work that out, we get a 1 over 3. So that will give me a 4 over 5 x to the power of 5 over 2, and then we get a minus 10 over 3 x to the 3 over 2, and we're not done yet. We now have to times everything by a third. And if you do that, you get 1 over 3 times by 4 over 5. 1 over 3 times by 4 over 5, that will give me a 4 over 15 x, okay, to the 5 over 2. And then if I do 1 over 3 times by 10, that will give me a 10 over 9 x to the 3 over 2. And then we just need to add our plus c. So for question 2, for the first question, we have f of x equal to 4x cubed plus 5x squared minus 10x plus 4a. A is a positive constant, and they tell us that given that x minus a is a factor of f of x, show that it's equal to this expression with a in it. So for the factor of f of x, then what does that mean? That means that f of a is equal to 0. So effectively, we just need to put f of a into this equation, make it equal to 0, and we should get that expression. So if we do that, if I just make it smaller bit so I can see it, we would get a 4a cubed plus a 5, not x, a squared minus 10a plus 4a, and that would need to be equal to 0. So if we just work this out now, so working this out, we get a 4a cubed plus 5a squared, and we get a minus 6a is equal to 0. We can take out a factor of a, so we a, then in brackets a 4a squared plus 5a minus 6 is equal to 0. And was that the form they want it in? Yes, that was the form they want it in. So yep, that is part A done. And with part B now, it just says we need to find the value of a and then use algebra to find the exact solutions of the equation f of x equal to 3. So for that first bit, for part B, okay, all we need to do is to find the value of a, we just need to find the solutions of a. So fairly simple. We know that a is a positive constant, so even though we get a is equal to 0 as a solution, we don't include it. So really, we just need to work out the quadratic, okay? So we need to work out this quadratic here, 4a squared plus 5a minus 6. Then the question at the top, it does say you must show all your stages of working, okay? So because it says that, it means that we can't just plug this into our calculator. We need to really show our workings of the quadratic here. So therefore, we will have to work this out. Now, to work this out, loads of ways you can do it. I like to do it this way. So we're going to do 4 times minus 6. That's a minus 24, okay? And then what I'm going to do is I'm going to think of two numbers which can sum to make a 5 and multiply to make a minus 24. In this case, I know that's going to be 8 and 3, okay? So it will be a positive 8. So a positive 8. So we'll have a positive 8a here, and then we will have a minus 3a here. And now what that means is effectively now we have a 4a squared plus 8a, and then over on this side we'll have a minus 3a minus 6, and I'm going to factorize these separately. So if we do that, we get a 4a, and that's an a plus a 2. And then on this side over here, we would get a minus 3, and then we also get an a plus a 2, which is perfect. That's what we want. Therefore, what do we know? We know that if we're to factorize that, it would be a 4a minus 3, and then a plus 2. Okay, and now we can work out our solutions at this point, which would give us a would be a 3 over 4 and a minus 2. Now, in the question at the top, it says that a is a positive constant. Therefore, we choose our positive value here. So we get 3 over 4 and minus 2. Therefore, our answer would just be a is equal to 3 over 4. And then there's that one last question. We need to use algebra now to find the exact solutions of the equation when f of x is equal to 3. Okay, so now if I quickly rewrite what f of x was over here, f of x was, it was a 4x to the 3 plus 5x squared minus 10x, and then it was a plus 4a. And then we know that is equal to 3. We now know our a value is 3 over 4, so therefore we would get a 4x cubed plus a 5x squared minus a 10x, and then a 4 times a 3 over 4. Okay, 4 times a 3 over 4 is just going to be a positive 3. And then we have the equals to 3 as well. And then if we just work this out, well, the 3's would cancel out. So we have a 4x cubed plus 5x minus 10x is equal to 0. We can also take the factor of x out now. So we've got a 4x squared plus 5x minus 10 is equal to 0. And now we just need to work this out. So if you try and work this out like the solution I just did earlier, you'll run into some problems, okay? Because if we do a 4 times minus 10, we get a minus 40. There are no two integers which can sum to make a 5 and multiply to make a 40. So we will have to use the quadratic formula or completing the square, any one you want to do. So in this case, I will use a quadratic formula on the 4x squared plus 5x minus 10. So the quadratic formula is a minus b plus or minus the square root of a b squared minus 4ac. And that is equal to, and that is over 2a. And now we can put in our values. So for us, we have the values where a is equal to a 4, b is equal to a 5, and then c is equal to a minus 10. So let's put all those values in over, let's do it over here. So therefore we get a minus b, so a minus 5 plus or minus the square root of b squared, so a 5 squared, that's 25, minus a 4 times another 4, so that's a minus 16, times a minus 10, so that is a positive 160, okay? And then over 2a, 2 times 4 is 8. So therefore, if we simplify this down a bit, we would get a minus 5 plus or minus the square root of 185 over 8, okay? And therefore, we've got our solutions now. We know x is going to be 0, and x is also going to be minus 5 plus or minus the square root of 185 over 8. For this question, all we need to do is show that the distance of OA is equal to root 38. So for this one, all we need to do is simple. It'll just be a 5 squared plus a 3 squared plus a 2 squared, all square rooted. Just a normal way of working out the length of things. And if you do that, you will get a 25 plus 9 plus 4, and then that gives us our root of 38. And for part B, we need to find the smallest value of a for which the distance of OB is greater than the distance of OA. So this question, what else do we know about a? We know a is going to be a positive integer in this question. Okay, that's what they give us here. They tell us that a is going to be a positive integer, so that is key. But for now, all we need to do is we need to effectively work out the distance of OB, and we all know the distance of OA. And then once we get to that stage, it will start to be a bit more clearer, okay? Because we have an unknown a in the vector b. So let's start by working this out. So first things first, what do we know? Well, if I write this in column form, we know that 2, 4a, okay? We know that has to be greater than a 5, well, we don't put the 532, actually, we can just put greater than root 38, okay, because we know that the distance of OA is 38. So if we work out the distance of B now, well, if we work out the distance of B, that would be like, it would be the square root of 2 squared plus 4 squared plus A squared, okay? And then that would be equal to, we work that out, well, 2 squared is 4, a 4 squared is 16, so that would give me a 20 squared plus A squared, okay? So what do we know? We know that the square root of 20 plus A squared has to be greater than the distance of OA, which is root of 38. Now we can work this out. We can get rid of the square roots. They can cancel out, so we're left with 20 plus A squared is greater than 38. Therefore, A squared is greater than 18. And therefore, because A has to be a positive integer, okay, so this tells in the question, we know that A is greater than root of 18. Now remember, it wants a positive integer. It wants an integer for A. Root square of 18 is obviously not an integer. So what can we do? Well, we know with root of 18, we know that if we think about the square numbers between the root of 18, okay, we know that 16 and we have 25, okay? So what does that mean? That means that if we know the square root of 16 is less than the square root of 18, and then that's less than the square root of 25, okay, we know that 4 is less than the square root of 18, and that's less than the square root of 5. So we know that the square root of 18, we know that it's in between 4 and 5. Now, in the question, we want the smallest value where the distance OB is going to be greater than OA. Well, in this question, we know that 4 is going to be too little. It's going to be less than root 18. So it's not going to be the smallest integer, okay? It has to be 5, because 5 is the smallest integer we can have, because root 18 is smaller than 5. Therefore, 5 would be the smallest integer we can have. So therefore, answer to this question would be that A is equal to 5. So for this question, we have that f dash x is equal to 2x plus a half cos x. We know that the curve has a stationary point with x coordinate alpha. Alpha is small, and then we need to use a small angle approximation for cos x to estimate the value of alpha to 3 decimal places, okay? For this question, what do we know? Well, we know that the curve has a stationary point at x coordinate alpha. So what do we know? Well, we know that for this question, our x coordinate, or we know that if it's a stationary point, we know that our f, we use the blue pen, our f dash x, okay, that has to equal 0. And when that equals 0, then it will have that stationary point there. We're also told that we need to use a small angle approximation to work this question out. The small angle approximation for cos x, this is in your formula booklets as well, but it is 1 minus x squared over 2, okay? That would be the angle approximation for cos of x. So now all we need to do is, we've already been given f dash x, so we can just equal that to 0. So we would get a 2x plus a half cos x, okay, that would be equal to 0. And now we can use a small angle approximation now and substitute that in for our cos x. So if we do that, we get a 2x plus a half, and then we get a times by 1 minus x squared over 2, and that would be equal to 0. Oh, my bad, let me just double change this. It should be a 1 minus an x squared over 2, like that. Okay, and now at this stage, now let's expand the brackets out. So we get a 2x plus a half times 1 is just a half, and if that 1, a half times x squared over 2 would be minus x squared over 4, and that is equal to 0. And now let's multiply everything by 4 to get rid of the fraction. So multiply everything by 4, you get an 8x plus a 2 minus x squared is equal to 0. And then if we just rearrange this, make x squared positive, we get an x squared minus 8x, and then a minus 2 equal to 0. And now we've got a quadratic equation. Now again, there are no two numbers which can sum to make a minus 8 and can multiply to get a minus 2. So in this case, we have to use either the quadratic formula or completing the square. I will complete the square this time. So if we complete the square, we will get an x minus 4 squared, and then we minus the 16 from that, minus the 2, and then that will give us an x minus 4 squared minus 18 is equal to 0, which gives me an x minus 4 squared, that is equal to 18. And then from this point here, we can just do x minus 4, and that is equal to plus or minus the square root of 18, and we get x is equal to 4 plus or minus the square root of 18, okay? And we're not done quite yet. Let me just turn this. Let's turn the root 18 into a third because we can. So therefore we get x is equal to a 4 plus or minus. With root 18, think of the square number factors. In this case, it will be a 9. So that root 9 goes to 3. So we get a 3 root 2. But we are not done yet, okay? Because in the question, we're using the small angle approximation, okay? They tell us that alpha is small. So we worked out alpha, we worked out x now. We've got x as 4 plus or minus root 2. So we know that one of those two values is going to be our alpha here. We know that alpha is small, okay, as they tell us. So really what we're going to do now is we've got to pretty much choose the smallest value to 0, okay, in this case. So if you work both these out, then if you work both these values out on your calculator, well, 4 plus 3 root 2, okay, 4 plus 3 root 2, that gives us an 8.2, okay, and so that's pretty big, so most likely it won't be that value. And if you work out a 4 minus a 3 root 2, okay, so put that in your calculator, you get a minus 0.243, okay. So as you can see, that one is close to 0, it's small, it's the smallest value. Therefore, in this question, alpha would be equal to 0, not just 0, it would be equal to a minus 0.243. The question wants it to 3 decimal places, and that is what we have given. Okay, and for the last bit, we have that the point P03 lies on C. We need to find the equation of the tangent to the curve at P, given an answer in the form of y equals mx plus c. So for this question, now that we've got our points, let me just on the next page. So right now, if I go back to this question, okay, what do we know? Well, we have the fact that x would be 0 in this question and y would be 3 because the point P is 0, 3. We just need to work out our m value, okay, our gradient. But we do know the fact that f dash x, okay, we know that that is equal to 2x plus a half cos x. So if we know that, we'll talk about our gradient, we just need to plug in our x value. In this case, our x value is just 0. So if we plug in f dash 0, okay, we get a 0 here for 2 times x plus a half cos 0. Cos 0 is just 1. So we'll be left with just a half. So we know that our m value, okay, our m value is a half. And therefore, this question, we don't even need to use the equation of a straight line. We can use the fact that, well, we have y is equal to mx plus c. The given of this question is that, for this question, if m is a half, because that's what m is, we just worked that out. And then we know what the y-intercept is because the point P is 0, 3. So that means the y-intercept must be 3. Therefore, we can just put straight away that c is 3. So the equation of this straight line would be y equals a half x plus 3. Okay, so for this question, we have the table of equations. This is for a curve of y equals f of x. And then they tell us that the trapezium rule is used with all the y values in the table. And they tell us that the approximate area under the curve is between 3 and 4. Given the area is 17.59, we need to show that a plus 2b is equal to 51. Okay, so for this, simple. We just need to use the trapezium trapezium rule formula. This is in your booklets. So what do we know about this question? Okay, well, we know that we need to look at h first. Okay, h is the first thing we want to work out. So we know that h, this is in your booklets too, is equal to b minus a over n. So a is a number, I guess the way you can think of it is b minus a, well, that is simply just going to be the 4 and the 3, okay? Those are our limits, so 4 minus the 3. And then with n, be careful not to just put it as 6, okay? Because effectively it's like it's the number of strips, okay? So it's pretty much like, think about it as it's like the in-between segments, okay? It's like in the in-between parts, okay? So it's not just 6, it would be like 1, 2, 3, 4, 5. Just remember that, don't put 6 down, it would be 5, okay? It's like we want the values kind of in between, if that makes sense. So therefore it would be 5, okay? So h is just going to be a 1 over 5. And because h is going to be 1 over 5, well, that's our h. Now we could just put in our values. So right now we have that 1 over 2 times 1 over 5. So right now we have a 1 over 10. Okay, that's the 1 over 2h. That's 1 over 10. And now we just need to put in our values. So if I scroll up a bit, well, for our y0 and yn, you can see that we have the a. That's our y0 value. So that will be an a here. And then our yn value, okay, if I just change this needs to be closed bracket like that. Our yn value, that's the last y value, in our case that's 13.5. Okay, and then put the brackets here like that, and then that is plus 2, and then that is all our values in between. So that'll be a 16.8 plus b plus the 20.2 and plus the 18.7. Okay, and what do we know about this? Well, we know that this is equal to the area, or an estimation for the area, which we're told is 17.59. So if we times everything by 10 now to get rid of that 1 over 10, then that would be a 175.9. And then what would that be equal to? Well, that would be equal to a plus a 13.5. Okay, and for this next bit here, if you used to work all that out, so if you used to do 16.8 plus 20.2 plus 18.7, work the sum of that out, and then times it by 2, you get a 101.4, and then would have the 2 times b, so you get just a 2b here. Okay, and now we're at this stage. Now we can just add up the 13.5 with the 111.4, so we get 175.9 is equal to a, and that would be a plus 2b, and that would be a plus 124.9. And now we can just, if we do 175.9, take away 124.9, well, that gives us exactly what we want, which is a 51 exactly, and that is equal to a plus 2b. Therefore, we've shown that a plus 2b is equal to 51. And for that part B, it says, given that the sum of all the y values in the table is 97.2, we need to find the value of a and find the value of b. Okay, so in that case, we already have this equation here, a plus 2b is equal to 51. So that can be like one equation. To find the second one, fairly simple. We just need to add all our values up together in that table and then equal it to 97.2. Okay, fairly simple. So if we go and do that now, well, if we add up the 16.8 plus the 20.2 plus the 18.7 plus the 13.5, then what do we get? Okay, if we add up all those values, so let me add them up now. So we get a 16.8 plus a 20.2 plus an 18.7 plus a 13.5. Add them all up together, you get a 69.2. So therefore, if we look at here, we know that a plus b plus the 69.2. Okay, we know that a plus b, okay, plus b plus the 69.2. We know that's equal to a 97.2. And then we could just take that 69.2 away, so that'll be a plus b is equal to exactly 28. Therefore, we have a plus b is equal to 28. We also have that the a plus 2b is equal to 51. Okay, we have these two equations here. Loads of ways you can do it. If we just do that, the equation 1, take away equation 2, because that will simplify down nicely. The a minus a will cancel out. We get 2b minus a b. So we get 2b minus a b, which is a b, okay? And then 51 minus 28 is 23. So we get b as 23. So now if I go over this page, we now know that b is equal to 23. And if we got b is equal to 23, well, the rest is fairly simple now, because we also know that a plus b is equal to a 28. So therefore, we have an a plus a 23 is equal to 28. So we know that a is equal to 5. Okay, worked out two values. A is 5 and B is 23. First question on question 6, we are told that A is equal to log base 2x and B is equal to log base 2x plus 8. We need to find express these terms in terms of A or B. So for the first one, log 2 of the root of x. So for this one, all we need to do is that if we have log base 2 of root x, we can rewrite that as a log base 2 of x 2 1/2, and then we can just bring that half to the front. Okay, so it's a half of log base 2x, and log base 2x is equal to a. Therefore, for that first question, we just substitute in a now, so we just get a half a. So that's the first one done. For b, we have log base 2x squared plus 8x. So already it looks like we can get this into some form of x plus 8, so we can input b. So for this one, what we want to do is we want to factorize this. Okay, so if I write it here, we have log x squared plus 8x. We want to factorize this. If we factorize this, this is log base 2 as well, and put it here. We'd have a log base 2 of x and then x plus 8, like that. And then again with log rules, what we can do is if we have two things being multiplied like this, that's the same as log base 2x plus log base 2 of x plus 8. And therefore, as we can see, log base 2x is a and log base 2x plus 8 is b. So it would just be a plus b. Okay, and for the third one, we have log base 2 of 8 plus 64 over x. So this one is a bit more challenging. Okay, we have log base 2 of 8 plus 64 over x. But as you can kind of see already, again, this is similar to like x plus 8 in a way, because we have the 8 and then we have the 64. So first thing we can do is we want to try and get it in the form of, we want to get x plus 8. Okay, we want to get x plus 8 because that will really help us. So we need to think about how can we get x plus 8 in the brackets. Okay, what do we have to take a factor of out? In this case, to get it as x plus 8, we need to take a factor of 8 over x out. Okay, and by doing that, we are left with an x plus an 8. Okay, so really these questions, you're just going to get it in the form you want. So we take a factor of 8 over x out, that leaves us with x plus 8. Now all we have to do is figure out what we're going to do with that 8 over x. Well, again, with the 8 over x, what we can do is we can effectively break all this up. So we would have a log base 2 of 8 over x, okay? And that would be plus the log base 2 of x plus 8. And now that we've got it in this form here, we can even break up that log base 2 8 over x. So that will be a log base 2 of 8 minus a log base 2 of x. And then we still have that log base 2 of x plus 8. And now we can work this all out. If you work this all out, well, log base 2 8, that's just 3. And then the minus log base 2x, that's just a minus a. And then log base 2x plus 8 is just b. So we're left with 3 minus a plus b. So for this question, we have to state the range of f. Okay, so with f, if we look at f of x, okay, we need to pretty much figure out the y values or the f of x values. So we've got that square root of x minus 2. Now, similar to a square number, we know that the square root of x minus 2, okay, if you think about anything you do with that number, it's going to be a value greater than 0, okay? So we know that. So we know that we're going to get a value. It doesn't matter what value we put in for x, as long as x is real, and using our domain, as long as it's real and it's above 2, we know that any value we put in there, it should give us a positive number, okay? So we know that. So therefore, if we know the square root of x minus 2 is greater than 0, Therefore, we know that if we just plus 3 to both sides, then 3 plus x minus the square root of x minus 2 will be greater than 3. And therefore, that must be our range, okay? Our range is all values greater than 3. Therefore, we can write something like f of x is greater than 3. And for part B, okay, part B, we need to find the inverse now of f1. So the inverse, so in this case, if f of x is the 3 plus the square root of x minus 2, then to work out the inverse, we effectively, let me write here, so we have y is equal to a 3 plus the square root of x minus 2. The inverse is just going to change your x and y values around. So now we have 3 plus the square root of y minus 2, and then just rearrange for y. So if we do that, we can get rid of that minus 3 first, or bring it to the side. So x minus 3 is equal to the square root of y minus 2. And then we can square root both sides. I mean, not square both sides. So we have x minus 3 squared is equal to a y minus a 2. And then we can simply just bring that y to, not the y, the 2 to the side. So we get 2 plus x minus 3. And that is squared. So we know that f minus 1 of x is going to be a 2 plus x minus 3 squared. And remember these questions, when you find the inverse, you've got to state the domain as well. Now, the good thing about these questions is, with these questions, the range of f of x is always equal to the domain of the inverse, okay, of f minus 1x. So if in the previous question we worked out that the range of f of x was greater than 3, therefore in this question, the domain would be the exact opposite, okay? So if we state that here, it would just be when x is greater than 3, okay? Okay, for part C, we need to work out g f of 6, okay? So we've got g of x here, we need to work out g f of 6. So first thing first, let's work out what f of 6 is and put that into g. So if I do the next page here, let's do g of 6, okay? Or not g of 6, f of 6, okay? So f of 6, what would that be? That would be a 3 plus x, so that would be a 6 minus 2, okay? So that is a 3 plus the square root of 4, which is a 3 plus 2, which is a 5. So we know that f of 6 is equal to 5. If f of 6 is equal to 5, then we know g of f of 6 is really just g of 5. So now we work out g of 5, okay? And g of 5, that would just simply be a 15 minus a 5, not minus, over a 5 minus a 3, which is a 15 over 2, which gives me a 7.5. And now for part D, okay, for part D, we need to find the exact value of the constant a for which f of a squared plus 2 is equal to g of a. So effectively, we just put the a squared plus 2 in for x into the f of x function, and then we put a also into the g function. We just work out what a is, okay? So for this question here, if we do that, that would be a 3 plus the square root, okay, and then that would be the square root of a squared plus 2, so that's what x would have been, right, minus 2, and then we put g of a, well, g of a would be a 15 over a minus 3, and we just need to solve that now. So first thing we can do is we can get rid of the 2's in the square roots. That'll be a 3 plus the square root of a squared is equal to a 15a minus 3. The square roots would cancel out on that left side, so we'd be left with a 3 plus an a is equal to a 15 over a minus 3. And then we just need to, we can times both sides by a minus 3. So if we do that, we get an a plus 3, a minus 3, and that's equal to a 15. If we work this out, we get an a squared, this is the difference of two squares, so we get a squared minus a 9 is equal to a 15. Then we get a squared is equal to a 24, and therefore this question, okay, we would get an a is equal to plus or minus the square root of 24. Now, does 24 have any square number factor? Yes, it does. It has 4, okay? So 4 and 6. So we get a plus or minus 2 root 6. And then in this question, okay, we got a is equal to plus or minus 2 root 6. Now, in the question, we've got a, okay? Well, what do we know about a? We know that if we look at a, okay, a, we're looking for in the f of x function, okay? We know that a is greater than 2, okay? So we have two values here. and we know that while x is real, x has to be greater than 2. So in this case, if we're substituting in a for x, it also has to be greater than 2. So for our two values here, we'd have to choose the one greater than 2. In this case, that would be 2 root 6. So a is equal to a 2 root 6. So this one, we have this stage here, and then we need to show that OC is equal to 12 meters. So OC, that would just be this line here. Okay, we need to show that this line here, that is equal to a 12. Okay, so how do we do that? Well, all we need to do is to work out the length like that. As you can see, that is the length of OC. OC is effectively the radius of that sector, right? It's the radius. So how can we work that out? Well, we can use the normal way to work that out, which is if we already know the arc length, which we do, the arc length is the 27.6. Okay, and we know that 12 must be the radius. Well, we can use the formula of so if I just make this part A, we can use the formula of L is equal to R theta. Okay, so we know L in the question, the arc length, they tell us here is 27.6. So we know that the arc length is 27.6. We know that's equal to R theta. Well, what is theta in this question? We can just look. They tell us that theta is 2.3 radians. So therefore, it's just going to be a 2.3 R. And if you do 27 over 6 divided by 2.3, you will get exactly 12. So we know that the radius is 12. For part B, we show the size of angle AOB is equal to 0.421 radians correct to 3 decimal places. So angle AOB, okay, so that is this angle here. That is the angle we want to find out, okay? So if that's the angle we want to find out, okay, let's call this theta. If that's the angle we want to find out, then how can we work out that angle there? So what I'll do in this question is, we're told in the question that there are two congruent triangles, okay? We know ABO, so we know ABO and we know GFO. Okay, they are both congruent triangles. So they have similar triangles. They are pretty much the same. So if we know that, then what do we know about angles like this, okay? We know that if I just draw a little diagram here, we know that this is effectively what we have. Let me make that straight line here like this. And we have this here and that. So what do we know? We know that this is 2.3, okay? And we know that in this case, angles on the straight line like this, they must equal 180 degrees. Or in this case, because we're dealing with radians, they must equal pi. So we would have an angle here, okay? So let's call this theta, and let's call this one theta. We know that must equal pi radians because it must equal like equivalent to 180 degrees, right? Because if ABO and GFO, they're congruent, they're similar, they should have the same angles. So we know that from just looking at that, we know that a 2.3 plus theta, it must equal pi. So therefore, 2.3 plus 2 theta must equal pi. Therefore, theta would just be a pi minus 2.3 over 2, okay? And if you put it into calculators, so if you're doing the calculators, you get a pi minus 2.3 over 2. 2, the question wants it to 3 decimal places. You would get a, if I just keep this here, you will get a 0.421 radians, okay, to 3 decimal places. So we know that angle theta, there is 0.421 radians. So for part C, we're told that the length of the front of the stage BCDEF is 35 meters. We need to find the total area of the stage, giving an answer to the nearest square meter. So if we know that BCDEF is 35, so that is this line here, BCDEF. We know that is equal to 35, and that actually helps us out because we can actually figure out what the line BC and EF are. So again, if I just do this up here, let me get rid of my part B. If we do this up here, So right now we know that if we know that a BC and EF, we know because it's all congruent, we know that they're going to be the same. So effectively, let's say that that's 2BC, okay? That 2BC, all I've done is that's just the BC and that's the EF. We know they're going to be the same. Let's just call it both BC for now. So, 2BC plus the 27.6, well, that's equal to 35. Because they tell us that BCDF is 35 meters. So if the CDE bit, if that is already 27.6, we can just work out what BC is. So now we can work out what BC is. If we do 35 take away 27.6, we get a 2BC that is equal to a 7.4. So BC is equal to a 3.7, okay? So that if I use the purple one this time, we know that this length here, we know that length is a 3.7. We also know that the EF, okay, that is also going to be a 3.7, okay? So we have 3.7 there. Okay, now we need to work out the area of the whole triangle. Not the triangle, the stage, okay? So as we can see, we've got this triangle here. How can we work out the triangle? Well, we know what this triangle is from part B. We know that this triangle here, okay, we know that is going to be a 0.421. Okay, we also know that this will also be a 0.421. Okay, so work that out. What else do we know about this triangle which we can use to help us work it out? Well, we actually know one other thing. We know that O is like the center, okay? If O is the center, then it's fairly certain that AO would equal OG, right? Therefore, we actually know this length as well. We know this length is going to be a 7.5. This will also be a 7.5. Remember, they're congruent, so they are going to be similar. Everything is going to be nice and symmetrical. So we know that's 7.5. Okay, and now with that triangle, we can work out the area of the triangle because what we have now is we've worked out, we know the length of BO. We know BO is going to be that 3.7 plus the 12, right? So we know all of BO, if I write that like here, we know that BO is going to be 15.7, okay? Because that's just going to be a 3.7 plus a 12. We know that AO is going to be a 7.5. And we have the included angle as 0.421 radians. Therefore, we can use the area of a triangle, okay? We know that the area of a triangle is just going to be a half AB sine C. And now we can use that because we have the two sides and the included angle. So if we use that, we can work out the area of of both triangles, and then after that, we just need to work out the area of that sector and then just plus them together. So if we work out the area of a triangle first, that would be a half times A. Let's say A is 15.7, and then times by that 7.5 times by a sine of 0.421. Now make sure that you're in radians. If you work that out, you will get 24.06. Okay, we get 24.06 two decimal places. Now that means that let's use the blue one. Let's use the orange. That means that this area here is 24.06. That also means that this area here is also 24.06. So therefore, we need to times our answer by 2 or plus itself. And if we do that, we get, if we times this by 2 now, we would get to, let's say, one decimal place, we would get a 48.1. Okay, so now we have the area of the triangle. Now what we need to do is work out the area of a sector. So I'll do it over on this side here. Okay, the area of a sector now. The area of a sector is, so if I write here, area of a sector. Okay, we know the area of a sector is, just do it here, is a half r squared theta. Okay, that is the area of a sector, half r squared theta. Well, we've already worked out the radius, and we already know the angle in between. So therefore, it's just going to be a half times r squared, which is 12 squared, and then times by the theta, which is 2.3. And if you work that out, we get 165.6. And now all we need to do is just need to add our values together, okay? So we've got 165.6. So we know that this is 165.6. This area here is 165.6. Then it's very simple from this. We just do 165.6 plus the 24.06 plus 24.06, which we worked out is a 48.1. And then what does that equal? That equals 214 meters squared. So we know the area of the stage is going to be, I've rounded it up to the three significant figures. It will be 214 meters squared. Okay, question 9. We have the first three terms of this geometric sequence, and we know that k is a constant. Show that k satisfies this equation here. So with this question here, well, what do we know? If it's a geometric sequence, that means that we are multiplying by the same value each time. Therefore, we can think of it as times r, okay? Because whatever our r value is, that will give us the next value, and then we times it by that same value again, and we get the next value. Therefore, what we can think of this is, effectively, we would know that in this case, it would be something like saying that 3k plus 4 times r is equal to the 12 minus 3k. Therefore, we know that r would have to equal a 12 minus 3k, okay, over a 3k plus 4. And if we know that, then we also know that for that second and third term, it would be the exact same. We also know that r would equal a k plus 16 over a 12 minus a 3k. Okay, mind my handwriting, I'm sorry for that. And if we know that, well, now we can just, because r is the same value, we can just put, make them equal to each other, and then we can work out our k value. So we get a 12 minus a 3k, and that is over a 3k plus 4 is equal to a k plus 16, and that is over a 12 minus 3k. And then we can just cross multiply now. So let's do it over here. We get a 12 minus a 3k, 12 minus a 3k, and that is equal to a k plus 16, and then a 3k plus 4. Okay, and now we just need to work these out. If we do that down here, we get a 144. We get 12 minus a 36, then another 36, so we get a minus 72k. And then a 3k, another 3k, that'll be a positive 9k squared. And that is equal to a 3k squared. We get a k times a 4, which is 4k. A 16 times a 3k is 48k. 4 plus 4k plus 48k is a 52k. 16 times 4 is a 64, okay? Now, you just need to bring everything on the same side. Just bring everything to the left side. We get a 6k squared. Bring that 52 over. We would get a minus 124k. Okay. And then we get 144. We get a minus 64. So that'd be a positive 80 is equal to 0. And now, as you can see, everything goes into 2. So therefore, we just divide everything by 2. We get a 3k squared minus a 62k plus a 40, and that would be equal to 0. So for part B, we are told that the sequence converges. We look at the value of k, and then also find the value of the sum to infinity. So for this question, find the value of k. Well, we know the sequence converges, so we know that our r value, okay, if I do that here, we know that our r value, the modulus of r has to be less than 1, okay? When a sequence converges, the modulus of r, our common ratio, it has to be less than 1. So we need to work out our k value first. So let's work out our k value first, and then once we work out our k value, we can put it into, like this question, for example. We can put it in to one of these r equations to get our value for r. So for our k value, well, we need to get the value of k, and that's a quadratic equation, so we can work that out. Now in this question, it does not say anything about using your calculator to get your solutions, okay? So to save time, just use your calculator, put it into your calculator to get your quadratic. If you do that, we would get a k as 20, and we would get k as 2 over 3. Now, you're probably thinking, oh, we get 2 over 3, it must be 2 over 3. And you just plug 2 over 3 into your equation to get r. But remember one thing, okay? Remember, don't just plug 2 over 3 in and think that it's getting confused with your r value. This is not your r value, it's just your k value, okay? Once we do this, we need to use this k value and then plug it into our equation for r to get the r value. So if we do that, let's use the 2 over 3 first, okay? So if we use the 2 over 3, that would be r is equal to a 12 minus a 3k, okay? And that would be over 3k plus 4. So if we work this out now, we get a 12 minus a 3, 2 over 3, and then that would be 3 times 2 over 3 plus 4. If you work all of that out, you will get a 5 over 3. Now, the problem with 5 over 3 is the modulus of 5 over 3, the absolute value, is not less than 1, okay? Because 5 over 3 is like 1.6 or something like that. It is not less than 1. Therefore, k cannot be 2 over 3. Now, let's do the same thing with our 20. If we do r is equal to a 12 minus a 3 times by 20 over a 3, 20 plus 4. If you work this out, you get a minus 3 over 4. And the absolute value of a minus 3 over 4, well, that is just a 3 over 4, that is less than 1. Therefore, we need to use when k is equal to 20 for this. So if we know that k is equal to 20, well, first things first, let's write the equation. So we know that the sum, when the sequence converges, is going to be a over 1 minus r, where in this case, a would be our first term and r would be our common ratio. Now, we know just from working it out that r is minus 3 over 4, okay? Minus 3 over 4, that converges. And we look at our first term now of the sequence. Well, in this question, we know that this 3k plus 4, that would be the first term. So we need to do 3k plus 4. If we do 3k plus 4, so that would be a 3, k is 20, plus 4, that is a 64. So we know that a is equal to a 64. So we worked out a is 64. We know r is minus 3/4. Then our s to infinity is simply going to be, it will be that 64 over 1 minus a minus 3 over 4. So it's a 1 plus a 3 over 4. So that is a 64 over a 1 plus 3 over 4. That is a 7 over 4, which is a 64 times by 4 over 7. Therefore, our answer, our sum to infinity, this converges at 256 over 7, okay? And you can leave your answer as that. The sum to infinity would be 256 over 7. This question, we have a circle here, and we need to find, in terms of k, the coordinates of the center C and the radius of C as well. So this question, we need to do a bit of completing the square first. So if we complete the square, what do we get? Well, let's rearrange this. Let's put all our x's together first. Okay, so x squared plus 6kx. Get our y's together. So y squared minus 2ky plus 7 is equal to 0. And now let's complete the square. Let's get the center of the circle and the radius. So if we complete the square now, we'd get an x plus a 3k. That'll be squared minus, well, we'll come out of that, a minus a 9k squared. Okay, that will come out. And then we have plus a y minus a k squared. And then out of that, a minus k would come out, a minus k squared would come out, plus a 7. And that is equal to 0. And then if we rearrange this, we get an x plus 3k squared plus y minus k squared. We get a minus 9k squared minus a k squared. So that'd be a minus 10 squared. So then we bring it to the side, it will be a positive 10k squared. And then we have a plus 7, bring it to the side, that will be a minus 7. So therefore, we know our center and our radius. We know that our center would be, so center would be a minus 3k, then a positive k. Okay, that is our center. And we know that our radius, well, that would be the square root of this side on the right. So our radius would be a 10k squared minus a 7, all square rooted. Okay, so for part B, we need to we're told that the line with equation y equals 2x minus 1 intersects C at two distinct points. We need to find the range of possible values of k. So because it says that it intersects, then what that means is we're most likely going to have to use some form of simultaneous equations, going to have to make some equations equal to each other. And we're told that it intersects at two distinct points, so most likely we're going to have to use the discriminant as well. So first thing first, we can substitute that y value into the equation. So you can use the center of the circle. I think it's maybe easier to use this equation. It's easier to use this equation here. Substitute our y value into that one because I think it's a bit easier. So that's what I'm going to do. I'm going to substitute into the main equation, okay? So if I do that, well, let me rewrite this equation first. So if I do that, then if I substitute into the first equation, right, then what do we get? We get an x squared, okay, plus a 2x minus 1 squared. That was where the y squared was. Then we get the 6kx, okay, and then with that, we had a 2ky, so it's a minus a 2k, and then open brackets 2x minus 1, and then plus 7 is equal to 0. So now I need to work this out now. So fairly simple. We get an x squared. If I expand the brackets all out, we would get a 2x times 2x is a 4x squared. We get a 2x times a 1, which is a minus 2x, and another minus 2x. So we get a minus a 4x, and then the minus 1 times 1 is a positive 1, plus the 6kx, minus a 4kx, plus a 2k, plus a 7, and that is equal to 0. So now we've got everything in terms of just x's and k's. Okay, and now we just need to keep going and get it into a quadratic equation form. So we have an x squared plus a 4x squared. That would give me a 5x squared. Okay, we have a minus 4x, 6kx minus a 4kx. That is a positive 2kx. We have a 1 plus a 7 is an 8, and then we have that positive 2k, and that is equal to 0. So now if I write this into the quadratic equation form, we have a 5x squared. We have this 2kx minus a 4x. So if I rewrite that, it would be like a 2k minus 4, and then in brackets x. And then we just have the 8 plus 2k. Okay, and I'll write that in brackets as well. As we can clearly see now, we have the x squared coefficient, we have the x coefficient, and we have just a constant coefficient. We have in the form of a quadratic equation. And now that we've done that, we need to show that this intersects at two distinct points and find the range of values for k. So we know that discriminant, if it intersects at two distinct points, therefore b squared minus 4ac must be greater than 0. And in our case, we can do that. We have a as 5, we have b as 2k minus 4, and we have c as 8 plus 2k. And then we can use the discriminant to work this out. So if we do that, we get not 5 squared, we get a 2k minus 4 squared minus a 4 times a 5 times the 8 plus 2k. So 2k minus 4 squared, and this is all greater than 0. Then 2k minus 4 squared, that would give me a 4k squared. A 2k times a minus 4 is a minus 8k. Another minus 8k is a minus 16k. Minus 4 times minus 4 is a positive 16. Then we get a 20. Let's do it separately. We get a 28 plus 2k. That is greater than 0. We get a 4k squared minus 16k plus 16 minus 160 minus 40k. That is greater than 0. Now we have a 4k squared. We have a minus 16k minus a 40, that's minus 56k. And then we have a 16 minus 160, that is minus 144. We know that must be greater than 0, okay? Now, luckily for us, this does simplify down. Everything can be divided by 4. So, therefore, we get a k squared minus a 14k, and that is minus a 36, and that is greater than 0. Okay, so now I've got this inequality here. All we need to do is let's draw a little graph here, okay? Now, at this stage, I would say try and work this out. As you can see, there are no two integers which can sum to make minus 14 and minus 36. So again, you can use a quadratic formula. Or I would say in this question, again, in this question, it's maybe worth 6 marks. But as you can see, it does not say you cannot use your calculator to work out any solution. So for this type of question, to save time, you can put this in part into your calculator now. And if you were to do that, you would get two values, okay? You would get k, and that would equal 7 plus or minus the square root of 85, okay? So we get those two values. What does that mean? Well, if we draw the quadratic graph here, it will be a positive quadratic graph because of the positive k squared. It would look something like this. And we know we'd have two roots here like this. This one would be a 7 minus the square root of 85. This one would be a 7 plus the square root of 85. And we want it when it's greater than 0. If we want it when it's greater than 0, then it would just be these values here. Okay, it would just be these values here. So therefore, our answer, as we can see, what's the range of values? Well, it must be, the range of values is when k is going to be less than a 7 minus the square root of 85, or when k is going to be greater than 7 minus the square root of 85. So for this next question, we have this graph here. We're told that v is equal to a times b to the power of t, and we need to show that find the initial value of the phone. So initial value of the phone, well, we're told that if you want the initial value of anything, in these type of questions, it's going to be when t is equal to 0. Now, we're also given the coordinates there of 0, 3. So we know that when t is 0, we're actually at 3, okay? And the thing about this question is everything is going to be in terms of logs. So as we can see, log base 10v, okay, that is equal to 3. So there's not much we actually have to do here. All we have to do is, we want the initial value. We know that when t is 0, the v would be 3, or the log base 10v would be 3. Therefore, it's just log base 10v is equal to 3. And then, well, to work out the initial value of the phone, well, now we can just solve for v. And if you're doing this, that would be a v is equal to a 10 to the power of 3. So we have v is equal to 1,000, okay? In this case, that would be like £1,000. Okay, and our part B, we need to find a complete equation for v in terms of t, given the exact value of a and given the value of b to 3 significant figures. So for this one, again, we need to convert everything into logs, okay? So let's convert everything into logs. So if we do that, because we're dealing with log base 10v, we need to put everything into logs. So with log base 10v, that is equal to a log base 10 of a, b, t. Okay, and what we want to do is we want to get this in the form of y equals mx plus c, the equation of a straight line. Why do we want to do that? Because if you look in this question here, they tell us that it shows a linear relationship, okay? A linear relationship between log v and t. So already that tells us that it's a straight line. And also if you look at the graph, it's also just a straight line. So all we need to do is so once we work this out in terms of logs, we need to get it in the form of y equals mx plus c. Okay, something in the form of y equals mx plus c. But really, we want to get it in the form of log base 10v is equal to some value, right, in terms of log base 10 of t, okay, because t is effectively the x-axis, and then we'll have a constant value here. So that's what we're going to do now. So, actually, if I do this on the other page, okay, so we have, so this is part B. Okay, so we have that log, it's bigger as well. We have that log base 10v. Okay, we know that is equal to a log of base 10 a b to the t. Okay, now how can we rearrange this? We get a log base 10v. That would be a log base 10a. Okay, just using log rules, plus a log base 10 bt. And now with that t, we can bring that t to the front. So we have a log base 10b, and I'm going to move the t over to this side, so we get a t log base 10b plus a log base 10a. Okay, like this. And now, as you can see, if I just rearrange this a bit, that we have a log base 10b t plus a log base 10a. Okay, and as you can see, that is in the form we want. That's in the form of a straight line in this case. So we've got a log base 10b, therefore this would be our m value, and then all of that would be our c value. Okay, so therefore in this question, if we want to work out the values of a and b, well, we have an expression now. We know the gradient must be log base 10b. Now how does it help us? Because in the question, we're told two things. We're told that the line passes through the point 0, 3, and 10, 2.79. And that is shown graphically as well there. So we can look at the gradient of that line, and it must be equal to the log 10b, right? So if we work out that, therefore, if we look at the gradient using those points, that would be a 2.79 minus 3, okay, the change in y values, divided by 10 minus 0. Work that out, you get a minus 0.21 over 10, okay, and that gives me a minus 0.021. So worked out that our m value, okay, our m value is minus 0.021, and we know that from when we did logs, we know that our m value must also equal log base 10b. Therefore, minus 0.021 is equal to log base 10b, and now we can work out our b value here. So we've got a b value. That would mean that b is just equal to a 10 to the power of a minus 0.021. If you work that out to 3 decimal places or 3 single figures, that would be a 0.953. So we know that b is equal to a 0.953. And to work out a is fairly simple, okay? Because as you can see, the log base 10a, that is just our y-intercept, okay? And just like in the first question, if our y-intercept, if we intercept at 3, well, then it's surely just going to be the same as our initial value. It will be log base 10a is equal to 3. Therefore, 10 to the power of 3, this is equal to a, and therefore that is equal to 1,000. Okay, so worked out a as 1,000, worked out b as 0.953, and it wants us to, in the question, what does it want? It wants us to complete the equation for v in terms of t. So what does that mean? That means that if our v is equal to ab to the power of t, well, then it wants us to complete this equation. Therefore, our final answer would be v is equal to a 1,000 times a 0.953 to the power of t. So for part C, we're told that exactly 2 years after it was bought, the value of the phone is 320. We need to use this information to evaluate the reliability of the model, okay? So for this question, all we need to do is, we know that t in this case, okay, is t measured in years? No, t is in months, okay? So we know that if it's 2 years, we know that we make our t value 24 months, so t is 24. So pretty much what we do is, using the equation we just worked out, if we make t is equal to 24, we want to see if we get a value similar to 320. If we do, then it's reliable. If we don't, then it's not reliable. So if we do that here, therefore we would get a v is equal to a 1,000 times by 0.953 to the power of 24. Now, if you work that out, you will get to 2 decimal places. You will get a 314.94. And that is pretty close to 320. So therefore, you can say since, since 314.94 or 315, whatever we're going to put, is close to 320, the model can be considered as reliable. Okay, and that would be question 11 done. Okay, so this question, we have y is equal to sine x, x is measured in radians. We need to use differentiation from first principles to show that dy by dx is equal to cosine x. And they also tell us this, that when h tends to 0, sine h is, well, yeah. They tell us that when h tends to 0, we get that sine h over h is tends to 1. This again. So with this question 12, we get y is equal to sine x. We have to use differentiation from first principles to show that dy over dx is equal to cos x. And they also tell us that when h tends to 0, sine h over h tends to 1. And when cos of h minus 1 over h, also when h tends to 0, cos h minus 1 over h also tends to 0. So we have this thing they tell us. So what we can do is start off just doing it normally. So what is differentiation from first principles? This is in our formula booklets, but if I just write it here, we know that f dash x, that is equal to the limit as h tends to 0 of f of x plus h, and then that is minus f of x, and that is all over h. Okay, so we know this is in the formula booklet. So we just need to put that value in for our this value here. So we have sine x. Okay, so we know that f of x is equal to sine x. So therefore we just put this value in and see what happens. So we get the limit as h tends to 0. Okay, and that would be a sine x plus h. Okay, because f of x is sine x, because we know that f of x is sine x in this case. F of x plus h is sine x plus h minus a sine x. Okay, and then over h. Okay, that's the first bit. Now the second bit, what we're going to do is now for the second bit, what we need to do here is they also tell us that we can use without proof the formula for sine A when it's plus or minus B. Okay, that's also, I believe, in our formula it's 2, but we can also use that in this. So with this sine x plus h, when they tell us this, that means they want us to use the sine A plus B. So in this case, with sine x plus h, we need to expand out, but using that trig form, which is in your formula booklets. So if we do that, we get the limit as h tends to 0. Sine x plus h, what does that go to? That goes to a sine x cos h plus a cos h, not a cos h, sorry. Now go to a cos x sine h, okay, minus sine x, and then over h. Okay, so I just expand that sine x plus h out. That is in your formula booklets for you to look up. Okay, so now that we've done that, now as you can see, there's a lot of things we can do here. I think the best thing you can do is we want to get it in this form. So we want to try and get it in this form where we have sine h over h and cos of h minus 1 over h. Because if we can get it like that, then when we tend everything to 0, we can just change those values. Okay, so how can we get this in that value? Well, let's think of it. So first things first, we have a sine x cos h and a cos x sine h. So what we can do, first things first, is we can join the sine x with the other sine x. Okay, so if I do that, we can get a limit as h tends to 0 of, well, that will be a sine x. I'm going to open the bracket, so we get a cos h minus 1. Okay, and that's that. And then for the cos, we can just leave that as cos x sine h over h. So all I've done now is I've just brought that sine x with the sine x cos h, and I've just factored out the sine x. So now we get, and actually, let me do this in 2 steps. This would also be a h here as well. So that's all over h. Okay, so I've just done sine x cos h minus sine x over h, and I've just factored out that sine x, so we get a sine x, and then in brackets we get the cos h minus 1 over h. Okay, I've also done the same thing where I've also just made the cos x sine h over h into its own thing. Now, as you can see, this looks very similar to the form we want, and if I just do it again just to emphasize what we want, then if I do this again, we effectively have a sine x times a cos h minus 1 over h, okay? And then for this one, we have a cos x times a sine h over h. And in the question, they tell us that when h tends to 0, sine h over h equals 1, and cos h minus 1 over h equals 0. So now that we've got that, okay, this should be a h. Now that we've got it in that form, well, let's tend everything to 0. If we tend everything to 0, then as the h tends to 0, well, what do we get? Well, we get a sine x, okay? And I can write this on this line here. We get a sine x, and we have a cos h minus 1 over h. Well, as h tends to 0, that would tend to 0 as well, so this would just be a 0. And then we get a cos x, and as sine h over h, as h tends to 0, that would be a 1. So therefore we get a times by 1, and therefore our answer is just going to be a cos x. So for this question here, we need to find the complete equation of the model. So when they say that, all they want us to do is work out our a and b values and put them in. So what do we know? What information have we been given? We've been given two pieces of information. We've been given that the maximum vertical height of the carriage above the ground is 60 meters, and we know that the carriage starts at a circuit at a vertical height of 2 meters above that ground. So what does all of that mean? Well, let's start with, I think, the easier one. The carriage starts a circuit at a vertical height of 2 meters above the ground. What does that mean? All that means is our initial height is 2 meters. So when t is 0, then if I just do that here quickly, we know that when t is 0, we know that h is equal to 20. And for the maximum vertical height, okay, well, we know that this is a quadratic equation. So we know that the maximum height, that occurs at the stationary point, right? So it occurs at the stationary point. So we know that dh over dt, when this equals 0, okay, that would give us that we'd be able to work out our t value, okay, and our t value that would be like on the x-axis, so that would be where it happens, and we know that that is also the height of that is 60, so we know the coordinates of that. If we work out the stationary point, we'll know the coordinates of the maximum height, okay, and by doing that, that should hopefully help us work out what our b value is. So first things first, let's work out our a value first. So let's work out our a value first. So we know that t is 0 and h is equal to 2. Therefore, we can put that into our equation we've been given. So that will be 2 is equal to a minus b, okay, minus b, and then that would be a 0 minus 20 squared. So we get a minus 20 squared. And then if we work this out, we get a 2 is equal to an a. Sorry, my pen is just being annoying right now. We get a 2 minus an a minus a b, okay, and that would be a positive 400 because minus 20 times squared is just 400. Therefore, we get a 2 minus a minus 400b, okay? So far we've got this equation here. We've got a 2 is equal to an a minus a 400b. So we can't do anything with that yet. But what we can do now is we know that there's a stationary point happening. So we can work out the stationary point as well. So that's one equation. Let's call this just one. And now we're going to the stationary point. So we have that dh over dt. We work out dh over dt. Well, what do we know about h? We know h is, if I just do h first, actually, h is, so it's h is equal to an a minus a b, and then a t minus a 20 squared. So therefore dh over dt, okay, if we're to work that out, what would that be? Well, that a and b are constants, okay, so that a would just cancel out. And then if we think about that 2 would come down to the front, so we get a minus 2b, and then a t minus 20, and then if you differentiate t, you just get 1, so don't have to worry about that. Therefore, dh over dt is equal to a minus 2b, t minus 20, and then we can equal this to 0, okay? So, because we want the stationary point, okay? We know stationary point must have the maximum height. Therefore, we have 0 is equal to minus 2b times by t minus 20. Now, for this question, they tell us that a and b are positive constants. So that means that for this question, b cannot be 0. Therefore, the only way for this equation to equal 0 is if t minus 20 is equal to 0. Therefore, we get our t value, okay? We get our t value as 20. So what does that mean? Well, that means that the maximum vertical height is at 2060, okay? Because they tell us in the question it's 60 meters. Therefore, the coordinate of that point is 2060. And if we know that it's 2060, well, then what we can do is we know that 2060 lies on this quadratic graph, which means that if we just put 60 and 20 back into the original equation, we can now get our values for A and for B as well. We can get another expression. So if we do that, well, that would be A. If I do it up here, we would get a 60. That is equal to an A minus a B, okay? And that would be a 20 minus a 20 all squared, okay? And if you do that, well, you're just left with A is equal to 60 because the 20 minus 20 cancels out. That'd be 0 squared. So you're left with A is equal to 60. So now we know what A is. Now we need to look at what B is, and then we can use whatever one we want to use. So let's use the fact that we know that from the question above, or what we just worked out earlier, we know that, what was it? That one there. We know that 2 is equal to A minus 400B. Therefore, we know that 2 is equal to a 60 minus 400b. So minus 58 is equal to a minus 400b. And then if you work that out, you get b as 0.145. And therefore, we've worked out our two values. Worked out a is 60, b is 0.145. But we're not done yet. We have to write the equation now. So the equation is h is equal to a 60 minus the b, which is minus 0.145, and then in brackets t minus 20 all squared. Okay, so part B, we need to use the model to determine the height of the carriage above the ground when t is equal to 40. Very simple. Just plug in 40 for t and you'll get your answer. So if we plug in 40 for t, that will be a h is equal to a 60 minus a 0.145. 40 minus 20 squared, that's 20 squared. If you work all that out, you will get exactly 2 meters. So answer is just 2 meters. Okay, and for this next bit here, we have an alternative model now of the vertical height, and that is 29 cos 90 plus alpha plus beta, okay? And that is between when alpha is greater than or equal to 0, which is less than 360. Alpha and beta are constants. We define the complete equation for the alternative model. Okay, so how do we work this one out? Well, this one is, so what do we know? Well, we know that it's an alternative model, but the maximum height would still stay the same. So it would still have to cross the 2060, okay? It would still have to cross 2060. That is still going to be a point it will have to cross. It's an alternative model, but it still hits the same points. Therefore, what can we do to work out the maximum height of this? Well, what do we know? Well, if I rewrite this out, okay, we have h is equal to a 29. What was it? It was a 29 cos 90 plus alpha and then plus a beta, okay? So, what do we know about this? How can we work this out? Well, what about maximums when we're dealing with trig functions like sine and cos? We know that with sine and cos, right? We know that sine and cos, and in this case we're just like cos, okay? We know that cos x, it's only ever going to be between minus 1 and 1, okay? That is it. So really, what we do is work out the maximum of cos in this sense. In this sense, because cos of x can the highest value can be is 1 in this sense, okay? And we know that it's going to cross the point 2060. Well, we actually can work out our beta value straight away. So our beta value would just be the 60, and that would be equal to 29. And because all of cos, the maximum value of cos, we know the maximum value of cos is 1. It would just be 20 times 1 plus beta. Okay, because the maximum value of cos is 1. Okay, that'll give us the maximum value there. So therefore, that is just 60 is equal to a 29 plus beta. Therefore, beta is equal to a 31. So we worked out our beta value as 31. Now we need to work out our alpha value. Okay, so let's rewrite this now with our beta value. So we have h is equal to 29 cos of 90 plus alpha, okay, plus beta, which we now know that beta is 31. And now we can use the fact that we have the 20 and the 60 to now work out our alpha value, okay? So if we make h equal to 60 and t equal to 20, because we know that it crosses 20, 60, that would be a 60 is equal to a 29 cos. 9 times 20, that is 180 plus alpha, and that is plus a 31. Bring that 31 to the side, we have a 29 is equal to 29 cos of 180 plus alpha. And then divide by 29, we get 1 is equal to cos of 180 plus alpha. So let's rewrite this as a cos 180 plus alpha is equal to 1. And now we just need to solve this. But before we do that, let's look at our temporary limits. Okay, so we're told in the earlier part that 0, which is less than alpha, that is less than 360. So our temporary limits, just for now, that would be just need to plus 180 to everything. So that would be 180 is less than or equal to 180 plus alpha, which is less than or equal to 540. Okay, so when we look at doing our limits, that is the region we want to consider. So now if I draw a little cos graph here, we draw the cos graph, and then what do we know about cos graph? Well, we know cos, it starts up here, okay, and it's a bit bigger. It starts up here, that's when it hits 1, and then it goes down to 90, 180, 270, then 360, like that. Let me make it more symmetrical, so it's like this, and then I'll go back down, and then, yeah, you know, it just keeps repeating. And then what do we know about this? If I just draw in everything here, okay, we know that this is at the point 1, okay? So that is at 0 degrees. We know that this is a 90, 180, 270. So here we go, 360, that is this point here. This, it would be a 450, and a 540 is here. So if we look at between 360 and not 360, look at between 180 and 540, there's only one point that's going to be equal to 1. That is our 360 hit. So we know that that means that, if I use the purple one, that means that 180 plus alpha is equal to a 360. Therefore, our alpha value is simply 180. So now we've worked out alpha value, we've worked out our beta value. We need to write the general equation of it. That would be h is equal to a 29 cos of 90 plus 180, okay, and then plus the beta value, which was 31. So for part D, okay, it says given that carriage moves continuously for 2 minutes, give a reason why the alternative model would be more appropriate. Well, one thing I'll think of is this is a roller coaster ride, okay, so it's going around in circles effectively. It's going to do one circuit and then another circuit. It's going to repeat itself, keep repeating itself. And with trig equations like this, okay, the cos x is going to repeat itself every like 2 pi, right? Because that's how it works. So because the trig function is going to repeat itself all the time, then then it's definitely going to be better, okay, because it's going to repeat itself, and that's what we want. It's going to be more accurate. So we don't need to put too much for this. It's only a 1 marker, but just to give a reason why the alternative model would be better. Well, a reason why the alternative model would be better, if we do it here, is you can just say something like it will be more accurate. It will be more accurate because it will be more accurate because like something like, I don't know, the cos function will repeat values in cycles, right? Something like that, right? With our first question, with our first equation, it was just a quadratic. This one is a trig function, so it's just better because that cos function is just going to repeat cycles, okay? It's going to repeat cycles. You can go one step further if you want. You don't need to do this, but if we know it repeats every 2 minutes, okay, we effectively have that t is 120. And then if you put that into the trig equation, okay, we get 29, or we get h is equal to 29 cos of 1,260. That's 90 plus the alpha we know, and then that's 31. That would equal 2 meters as well. So what we're saying is every 2 minutes we're gonna effectively just do 2 meters of the roller coaster. But yeah, usually put something that would be more accurate because the cos functions, they repeat values in the cycle. So every 2 minutes we're gonna be doing 2 meters. Okay. So for question 14, we need to prove using algebra that n plus 1 cubed minus n cubed is odd for all n which is natural numbers. So first and first, let's consider that n is just all even natural numbers, okay? So let's say that n is equal to 2k. Then let's just put this value in, that 2k, into the n plus 1, right? Because 2k, that would be all just even natural numbers, right? It'll be 2, 4, 6, 8, 10, all the way to infinity, right? So let's just put that 2k in, and then using that 2k, we should be able to, once we put it in, prove that it will be an odd number. So if we do that, we get a 2k plus 1, and that will be cubed minus a 2k, and then that is just cubed, okay? If we work all this out, we get a 4k squared, we get a 4k plus 1 in brackets, and then we'd have another 2k plus 1. That'll be minus an 8k cubed. Okay, like this. And if we expand this out, what do we get? We get an 8k cubed, okay, plus a 4k squared. Then we get an 8k squared plus a 4k. Then we get a 2k plus a 1. And then we still have the minus 8k cubed. The 8k cubes there will cancel out completely. And then we're left with a 12k squared plus 6k plus 1. So now how can we prove that this is going to be odd? Well, what we can do is what we can do is where we have the 12k plus 6k, in these type of questions as proof, what you want to do is you want to write this like this. So 2 in brackets, then 6k squared plus the 3k, close bracket, and then add the 1 on the end. So what this shows is that with that 12k squared plus 6k, right, that is always going to be an even number because it was going to be 2 times something, and 2 times anything will always be an even number, okay? Okay, now we're at this stage. We've shown that we've got it in this form, that 2 times 6k squared plus 3k plus 1. Well, we know that this 2 times 6k squared plus 3k, that is always going to be even, okay? This is always going to be even. Okay, therefore, if we plus 1 to that value, we get a 6k squared plus 3k, and then plus the 1. This will always now be odd, okay? Because we're just plussing 1. If something's even and then we plus 1, it's always going to be odd. So therefore, if we have an even number, we plus 1, that is always going to be odd, okay? Therefore, we can say something like, use this pen, hence any even or any value for n which is we can say any value for n which is even will return an odd number, something like that. And then you can be all nice and say for all values of n which are natural, make it all, look all good and stuff. And then now we've done that, that's even numbers. Now we do the same thing but for odd, okay? So if I do odd on, let's do odd here. That's on the next page. If I do odd here, okay? So now for odd, we have choices. So we can use loads of values, just any values where we can get odd. So I'm going to use 2k. You can use 2k plus 1. but I'm going to use 2k minus 1 because I think that that is also going to give you an odd number, okay? So I'm going to use 2k minus 1 for my odd number. It's up to you. You can use 2k minus 1, 2k plus 1, 2k plus 3, whatever you want. I'm going to use 2k minus 1. Okay, so if I do 2k minus 1 now I need to put that in the form of n plus 1 cubed minus n cubed. Put that in that form here. This is now, so this is for odd, okay, because we know that now we're looking at when n is odd, okay? So now what we do is we need to do a 2k minus a 1 plus a 1 cubed minus a 2k minus 1 cubed. So that would be a 2k cubed. Okay, this is why I do it this way, because this way we get rid of that minus 1 and 1, and we're left with 2k cubed minus a 2k minus 1 cubed here. Okay, so when we solve this, we will get an 8k squared minus a 4k squared. Minus 1 times 2 is minus 2, so minus a 4k plus 1, and then that will also be another 2k minus 1. So we get an 8k cubed minus a 8k cubed minus a 4k squared. Then we get a minus an 8k squared plus a 4k, and then we get a plus 2k, and then we get a minus 1. Okay, and then the 8k cubes will cancel out. We're left with a minus 4 minus 8, so minus 12k squared, so a positive 12k squared with that minus on the end. A 4k plus a 2k is a 6k, so that will give us a minus 6k, and then a minus 1 times a minus 1, that is a positive 1. So we're left with 12k squared minus 6k plus 1, and similar to the first part of the question, let's take out the factor of 2. So now we're left with 6k squared minus 3k plus 1. Okay, and as you can see, it's exactly in the same kind of form as we just had earlier. Okay, we have 6k squared minus 3k plus 1. So because of this, okay, we have this k value. It doesn't matter what k is. We're going to times it by 2, and then so that's always going to be an even number. So again, we can say the same thing we did in the previous question, right? We can say that 6k squared minus 3k will always be an even number, and therefore 6k squared minus 3k plus 1 will always return an odd number. Therefore, we're showing it both ways. Therefore, just need to add something here. Therefore, no, let's do the other way. Therefore, we can write something like, hence, for all values of n, which is in the set of natural numbers, n plus 1 cubed minus n cubed will always return an odd number. Okay, and that's question 14. So for part A, as you can see, we need to differentiate this, and it's written as a fraction like this, so we should use the quotient rule. Okay, so what is the quotient rule? So if I just write the quotient rule down here quickly, we know that if we have something like this, f dash x is equal to g dash x hx minus g of x h dash x, okay? And then that is over h of x squared. Okay, that is a quotient rule. Just get our values. So let's say g of x, let's let that equal the numerator, so that will be 7x e to the x, and a h of x, that will equal our denominator. So in our case, that is the e to the 3x minus 2 to the half. Okay, now let's differentiate both of these. So differentiating this, we get a g dash x that is equal to. Well, differentiating this, we actually have to use, I guess, like a product rule, right? Because we have the 7x and we have the e to the x. So if we use product rule in my head, what would that be? Well, luckily for us, e to the x just differentiates to e to the x. So we'd get a 7x e to the x. And that's plus a 7 e to the x, okay? So that is g dash x. And then h dash x. What does that equal? Okay, so this one's a bit more hard, but it's completely fine. So this one, we know that when we differentiate this, that half will come down to the front. Then we need to differentiate, actually before we, let's differentiate the e to the 3x first. Let's get that out of the bracket. So that will be a 3e, 3 to the x, okay? And then we need to also have our whatever's in our brackets originally. So that's the e to the 3x minus 2. And then this would just be, you put the power down, so that's minus a half. So therefore, for that one there, it would be a 3 over 2 e to the 3x. Okay, 3 over 2 e to the 3x, and then all of that e to the 3x minus 2 to the power of minus a half. Okay, and now we need to put that into the formula. Okay, so if we put this into the formula now, we have g dash x times h of x. So if I write the h of x first, that will be e to the 3x minus 2 to the half. Okay, and that will be times by 7x e to the x plus 7 e to the x. And that is a minus g of x times h of x. In our case, that will be a minus 21 over 2x. Okay, 21 over 2x. And then we get an x times e to the 3x. That's an e to the 4x. And then we get an 3x minus 2 to the power of minus a half. And then all of that is over e to the 3x minus 2 to a half. It's all being squared, so that will cancel out. So if we move to the next bit, what we want to do now is if I rewrite this as e to the 3x minus 2 to a half, and then we have the 7x e to the x plus 7 e to the x minus 21 over 2x e to the 4x e to the 3x minus 2 to the half. We know that that is just going to be over e to the 3x minus 2, and that will be it. Okay, so in this question here, we see that with the denominator, we have this power to the 3 over 2. So what that means is we need to think about how can we get that 3 over 2 down to the bottom. Well, if we can times this value here by itself to the half, that will give us a 3 over 2. So really, we want to think about how can we bring this down to the denominator. Well, to do that, if we just can get everything to a factor of that, we can eventually just bring it down to the front, and then it will be to the power of 3 over 2. So for example, if I show you that here, if we take out a factor of this over here, e to the 3x minus 2 to the power minus half, take out a factor, that would be e to the 3x minus a 2 to the minus a half. Okay, in brackets, we would get an e to the 3x minus 2. Okay, that will be it for that no power, because obviously if we were to work this out, that would give us to the power of a half, which is this over here. So we can leave it like that, and then we also have the 7x e to the x plus 7 e to the x. And then for this one here, we would just have a 21 over 2x e to the 4x, okay? And that is all over e to the 3x minus 2. So now we can see we can bring that we can bring the e to the 3x minus 2 to the power minus half. We can bring that down to the bottom now. If we do that, we get an e to the 3x minus 2, 7x e to the x plus 7 e to the x. minus 21 over 2x e to the 4x, and then that would now give us e to the 3x minus 2 of 3 over 2. Now let's expand the brackets out. So we get a 7x e to the x of e to the 3x minus 2 plus a 7 e to the x of e to the 3x minus 2 minus 21 over 2x e to the 4x. Okay, I'm just going to focus on the numerator for now, and then I'll go back to the denominator in a second. Okay, so now we've got this. What can we do with this? So in the question, as you can see here, we on the numerator, we have everything. We have a 7 e to the x outside, so we need to take a factor of 7 e to the x. Okay, so that's what we're going to do here. We're going to take a factor of 7 e to the x out. So we'll just focus on the numerator for now. That would be a 7 e to the x. Okay, that would be x, and that's e to the 3x minus 2 plus e to the 3x minus 2. And then that would be a minus 3 over 2 x e to the 3x. It'll be to the 3x, okay, like this. And now if we start to expand everything out, we get 7x and then an x e to the 3x minus 2. Let's do it again. We get an x e to the 3x minus a 2x plus an e to the 3x minus 2, and then we get that 3 over 2x e to the 3x. Now we can just join our like terms together, still working on just the numerator. Okay, so with the numerator we get a 7 e to the x, and then we have that x e to the 3x and then minus 3 over 2 e to the x. So that is effectively like a 1 minus a 1.5x. 1 minus 1.5 is minus a half. So minus a half x e to the 3x, okay? And then we just have the e to the 3x, and then we have minus 2x minus 2. So now we're at this stage here, okay? And now what we can do is in our answer, we have this 2 at the bottom. So again, what we can do is we can just multiply both sides by 2. And if you do that, in this case, because we want 7 e to the x on the outside of the brackets, we're going to multiply inside the brackets. So we'll get a 7 e to the x, okay? And then we'll multiply everything in the brackets by 2. So we get a minus x e to the 3x plus a 2e to the 3x minus a 4x minus a 4. And then that is over the e, or the 2e to the 3x minus 2 to the power of 3 over 2. So now one last thing, we just need to now get it like this. So we need e to the 3x somewhere, and e to the 3x is fairly simple at this stage. So now we're nearly at the home stretch. We are nearly there, guys. One last thing is to put this now, get that e to the 3x there, so 7 e to the x. And then if you do that, you'll get an e to the 3x. As you can see, that will be a 2 minus x. We go inside here. Then we get a minus 4x minus 4. And we are done with that question. And that will give us the answer we want. Now, the way I did it is a long way, and I did show all my workings. Obviously, if you're in the exam, depending on your time constraints, you may be a bit low on time. So feel free to just, if you know it, just go do it. So all the workings like what I did. You can skip some of the steps, but obviously I just want to show you all the workings there just to make sure you know how to do it. Okay, so part B, we need to show the x-coordinates of the turning points of the curve are the solutions to this equation here, okay? So again, if we know that, then, well, if we look at our answer, we know that if that is equal to 0, because this is f dash x, okay? We know that if this is equal to 0, therefore, if this here is equal to 0, we know that that will give us our turning point. So that's fairly easy. We know that the denominator cannot be equal to 0, therefore the numerator has to be equal to 0. So we get 7 e to the x of e to the 3x. I'm sick of seeing this e to the 3x. I've seen it so much now. minus 4x minus 4. We know that is equal to 0. And therefore we need to work this out. So if we work this out now, we get a 7e to the x, and then let's expand this out, 2e to the 3x. Then we get minus x e to the 3x, minus 4x minus 4, and we do the square brackets equal to 0. And now we're in this stage, okay, we have 7e to the x, and we have this things in brackets which is equal to 0. Well, one thing we know is that due to this question here, 7e to the x can never actually equal 0, okay? It can never equal 0 because e to the x is always going to be a positive value. Therefore, we know that it has to be 2e to the 3x minus x e to the 3x minus 4x minus 4. Okay, that has to equal 0, okay? So now we know that has to equal 0. Therefore, we need to collect all of our terms together, all the terms we want. So in this case, if we put everything, so if I rewrite this, we have 2e to the 3x minus x e to the 3x, okay, minus 4x minus 4 equals 0. In the question, as you can see, if I scroll all the way back, we have this e to the 3x plus 4 on the bottom. So really, if we can get something in the form of x e to the 3x plus 4x on one side, then we can obviously take out the fact of x and then divide it. So that's all we need to do. And lucky for us, we have that exact thing. Okay, we have an e to the 3x and we have a 4x. So effectively, that'll be 2e to the 3x, okay, minus 4, and that's equal to an x e to the 3x plus a 4x. Therefore, if we take out the factor of x, we get an e to the 3x, okay, e to the 3x, and then we get a positive 4, and that is equal to 2e to the 3x minus 4. Therefore, x is equal to 2e to the 3x minus 4, and that is over e to the 3x plus 4, and this should be written down here. So that's e to the 3x minus a 4, like that. So for part C, we need to draw a staircase diagram starting from x1 is equal to 1. So as you can see, I've drawn that here. So that is at where x is equal to 1. And then what we need to do is we go across the y equals x line like this. And then that's that. And then we need to go back up to our curve. And then we go back here like this. And then we go back up to our curve like this. And effectively, that is our staircase diagram. Okay, it's 1 mark. So maybe if you haven't seen this before, don't worry too much. Maybe that's what a staircase diagram is. It's written like it's like a stairs, right? In this question, we just start at x equals 1. We draw a straight line up to the curve, and then we draw the horizontal line that goes to y equals x, and then we draw it back up to the curve, and then we draw another horizontal line back to y equals x, and then we just keep doing that until we get to our root, which is beta. Okay, so that would be that question done. And going on to question D now. So question D. Now we need to use the iteration formula when x1 is equal to 1, and then find the 3 decimal places, the value of x2 and the value of beta. Okay, so what do we know about x2? So we know that x2 would be 2e to the 3 of x1, okay? That is x1, that's minus 4. And then that would be e to the 3x1 plus 4, okay? So that would be x2. So if we put in our values, well, if x1 is 1, then that would just be 2e to the 3 minus 4. And then that would be e to the 3 plus 4. And if you work that out, you get 1.502. Okay, so that's x2. Now for alpha, okay, so that's the I. Now to work out the next value, okay, beta, I mean, beta is a similar thing. Now what we're going to do is we're going to use that answer we just got that 1.502, we're gonna keep repeating that iteration until beta is just the same, until it converges to some type of value. Okay, so I'm gonna use my calculator here. Okay, so you see on my calculator, what I've done is, I don't know if you can see this, but it's a bit hard actually. But what I've done is I've made it so I've just put my answer function back in now. And now I'm just going to keep hitting equals and keep hitting equals and seeing what number this converges to. So right now it's still changing a lot. Okay, I'm just hitting equals now. And as I'm going on my calculator, it's starting to converge to the same value now. And that value is to 3 decimal places. If I keep hitting equals, it's converging to 1.968. Okay, I'm hitting equals. And as you can see, now it's just stopped. Like I can't go anymore. It's just converging to the same value to 3 decimal places. That is just 1.968. So for this question, if we show that alpha is equal to 0.432, so for that question, effectively what they're saying is we need to pretty much put a value in when the x value is equal to 0.4315, and then when x is also equal to like a 0.4325. Okay, if we can put a value in for that, there should be a change of sign. So what do we have? We have the equation of x equal to 2e to the 3x minus 4 over e to the 3x plus 4. All we need to do now is, right now this isn't in the form, like we need it in the f of x form, right? But right now we have this x, so we just need to bring that x to the other side. Okay, so now what I'm going to do is I'm going to bring that x to the side, so we get 2e to the minus 3x minus 4 over e to the 3x plus 4 minus x is equal to 0. So we brought that minus x now to the other side. And effectively, if it's a root, we can say something like, we've already got f of x. So let's just say that g of x now is equal to 0. Therefore, we can say that g of x is equal to the 2e to the 3x minus 4 over the e to the 3x plus 4 minus x. And now we've got this form. And now, as I stated earlier, if we want to show alpha is 0.432 to 3 decimal places, we just need to put in both these values here now for x, and we should get a change of sign. Okay, so let's do that here. So if we start with, so if we were to put substitute in 0.4315 into x, okay? If you do that into your calculators now, so 0.4315 into the function, so we get 2e to the power of 3 times 0.4315 minus 4 over e to the power of 3 times 0.4315 plus 4 minus the 0.4315. If we put all x into that, we will get an answer of minus 0.0002. If we do the same thing, but now we do 0.4325, if we put that into our g of x function, we get a positive, use the orange color, we get a positive 0.0009. Hence, we have a change of sign. Hence, change of sign. Hence, there is a root in that interval. And that will be it for this paper. I hope you enjoyed it. I also have the 2024 papers up, so go check that out, and I'll have paper 2 out hopefully by next week, so you can also check that as well. But yeah, I hope you enjoyed this, and I will see you soon.